Hi, and today I wanted to introduce you to something that I hold very dear to me, something that is present right behind me that I hold very close to my heart. Yeah, not this dish, it's the skies. The skies right behind me. I love the skies, and I love watching these skies because they fill me with such a sense of awe, such a sense of grandeur. No wonder we call them the celestial heavens, not just, I don't know, 10,000 years ago. But yes, the sky still feels like something that we fully do not ever understand, something we cannot fully grasp. And something I love watching in the skies are the clouds. Because the clouds give me and fill me with questions, a lot of pestering questions that I could not answer and that I really wanted to answer. So today I wanted to delve into optics, to get a deeper understanding of what these clouds are that unfortunately do not occupy the skies today. It's a pretty empty sky, but to venture into clouds and to analyze what clouds are, and in hopes to answer some of my pestering questions about clouds.
So, clouds are quite fascinating. And when I see clouds in the day, I'm particularly given a sense that they are very fluffy and they are very circular, right? So, whenever I observe them in the day, I always start wondering why are they more fluffy than at night? And contrasted at night, they seem to have a certain layer of depth added, right? They have a darkness layer added that gives to give them a three-dimensional feeling. So why is that?
So, to answer this first question, I wanted to make it more interesting. So, I wanted to employ the scientific method and the scientific way of thinking about how this question might be answered. So, let us look at the question: why are clouds fluffier in the day and more three dimensional at night? Why, indeed, right? Why are clouds fluffy in the day and more three dimensional at night? Well, in the scientific method, if you're employing that, the first step is to come up with a hypothesis, come up with maybe a theory that could explain why this question arises in our minds. And how do you come up with a hypothesis? Let us walk with me. We read the question again, right? Why are clouds fluffier in the day and more three dimensional at night? Something that we're talking about are clouds. And that is always the first thing that I think a lot of hypotheses think about. Maybe it is the thing that we are thinking about. Maybe it's the clouds themselves. The clouds are to blame, you know? Maybe it has to do with the clouds. Maybe the clouds are different during the days and during the nights. Maybe the clouds are dependent on the time and they follow two cycles. Perhaps the clouds are to blame. So let us investigate clouds. Another valid hypothesis would be to maybe look at the time, right? Maybe we are looking at the day and the night, and something that is obviously different about days and nights, as you might have noticed from the introductory video, is basically during the day the skies are blue-ish in color, and during the night the skies are violetish in color. So maybe it has something to do with the background. Maybe the background is to blame, maybe that could be the case. Another way of looking at it is that another difference between the day and the night is you notice a lot of stars at night, right? Stars only appear visible at night, so maybe that has something to do with it. Maybe the stars being present and absent is the fundamental change. You have to look at changes within your area of interest, which is basically the day and the night. What are the differences between the day and the night? And so the third valid hypothesis would be maybe it's the stars. It's got to do with the stars. The stars are to blame, perhaps. And maybe the stars are interfering in some way. Very valid hypothesis. And the main difference that you might have just been wanting me to tackle is basically what if it has something to do with the sun and the moon? What if the sun and the moon are to blame? Right? That is the fourth hypothesis. Maybe it's the sun and the moon, maybe they are having a quarrel and they want to solve this. So, why are clouds fluffy during the day and why are clouds three dimensional during the night? That is answered through our next step. So, an important aspect and the next step of inquiry, as different from just asking normal questions, is analysis, my favorite step. Because when you ask a normal question, what you want is an answer, right? You don't want to implicitly understand something. But inquiry means you're inquiring about something, means you want to understand it in a sense that you get a sense of that question, that you can relive the question and retroactively arrive at the same answer again and again. You want a method to answer the question, not just an answer to the question. And an important aspect of finding the right method to answer a question is analysis. An analysis is when you dig deep inside of a question, when you try to find out what the question is all about, right? So when we look at this question, why do clouds appear more fluffy during the day and why do they appear more three-dimensional at night? We are analyzing properties of clouds, right? The property of fluffiness and the property of being 3D. And these two properties are directly tied to something that is called vision, that we observe, that we can see. And hence we have found our mode of analysis. What we are going to rephrase this question as is to ask the question in terms of sight, because that is something we want to analyze it further on, right? So when you look at this question, why do we see clouds as fluffy? Why do we see clouds as three-dimensional? That is the initial question. But if you notice, there is an implicit understanding here that can itself be questioned, and that is always something that you should analyze. Because why do we see clouds? Why we see clouds? That is the second question, an implicit question. But then again, there is another implicit question inside of that, if you can notice. What are clouds? What are these things that we observe? Can we classify it? Is that a proper definition? Well, one colloquial way of saying it is these are objects in the sky, right? They're not all objects in the sky, there are also birds, so it's not a proper definition, but we get a sense that it might have something to do with the sky, right? And since the sky is also present in our original question, it makes sense to answer. It does not make sense actually to answer the question, what are clouds, without answering the question, what is the sky? And when we try to answer what the sky is, perhaps from the grassroots level, then we can get a sense of what clouds are, and then we can possibly arrive at our answer.
So, to answer the question, what is the sky, we venture into the realm of optics. And in the realm of optics, the photon is the fundamental particle, the most powerful of them all. The photon is how we see things. The photon interacts with various objects in one of three ways. Well, it could either be reflected, or refracted, or absorbed, or a combination of any of those. So, how do we understand these phenomena? Well, I have a simple analogy. Let us imagine objects to be like goalposts. So, when a photon is incident on a particular object, it is kind of like kicking a soccer ball into the goalpost. So, let us kick a photon into the goalpost and observe what happens. One thing that could happen is that we kick it with a large force and the net bounces it right back at us. That is reflection. Another thing that could happen is we kick it and it does bounce it a little, but it stays inside the goal and it stays inside the object. That is absorption. Now, another thing that can happen is maybe the ball is very small and the nets are a little large for the ball. And in that case, it is possible for the ball to just go through the net. But what is more likely to happen is it's going to encounter a single thread from the net and deviate from its original trajectory, which is refraction. These are the three things that could happen. And mostly how we notice things, how we look at things, is because light is reflected and that information is carried to us. And we have this sense of whatever we can observe, we can usually touch and feel. Like, look at a tree. We can look at it and hence we can feel it, we can touch it. When you look at animals, it's something you could feel and touch. You look at a waterfall, yes, you could still feel and touch the stones in the water. So, what's different about the sky? Well, we would soon discover that there wasn't anything really physically touchable or feelable in the sky in a certain sense. And so by that time, we had discovered certain things that are optically present but not physically present. These things existed because of certain phenomenon, because of certain effects. So what is the sky? The sky is not something that actually exists. It's not a blanket. It's a phenomena. Which phenomena? Scattering. Now, scattering, that's not heard of, but we know reflection, right? That light reflects off of surfaces. Now, imagine you had a bunch of small, really small objects, right? Really small balls, kind of like our photon here. And these balls were present, but really far apart. So then you couldn't actually feel them when you put your hand through, right? But what happens to this photon? Well, if the photon is bouncy enough, then it bounces off, right? And blue light is a little more bouncier than other forms of light. So, what happens is it bounces around, it reflects. That happens once, twice, multiple times with blue light, in fact. And then you get a lot of reflections of these small particles of something that is not present as a whole but is seen all around the sky because there are a lot more photons than these small objects. And so we see this, but in turn, these are really, really small particles that you can't actually touch. So that's the conundrum, but that is what the sky is. So I also wanted to experimentally show that the sky is more blue. So this is a particular colloidal solution on the right hand side, which is kind of filled with particles at in the sky. And so when I'm shining a ray of light from a flashlight on there, even from the other side, you see that the clear water, this is filled with water on the left hand side. It does not showcase a trace of the path, but in the colloidal solution, you see a clear trace of the line, right? And although because of the glass, there is some refraction going on, but you can see that the light ray is particularly traced well. And so because of that, because of scattering, we get a color from the sky. It's not like water is not letting the light through, right? It's letting it through to the colloidal solution. It's just we cannot see it because it's not scattering the light to our eyes. And so with the sky, it's filled with particles that are kind of scattering the light and they are reflecting it back to our eyes. So we see that it's more apparent in darkness. So here we go. That sort of just looks like a clear glass, but it's filled with water. And here's a small distinction. I could not get distilled water, so the small amount of minerals that are there in complete darkness, even they show a slight scattering of light in a certain sense. Hence, why you can even see a small diminished ray. But those are not particles enough to give a really strong feeling like the one on the right does, and hence it's more of a colloidal solution than the one on the left. And so you can see that at least in dim conditions, that effect is negligible. If the sky was particularly clear, there would be no amount of light that you could see, no singular ray of light. And if you look at it generally, right, you have this sky that is light blue in color because it has particles. If it did not have particles like this glass of water, it wouldn't have any color. And so this is like a top down view kind of. You're seeing the complete bluish color over here from the skies through this experiment. So this shows how kind of the sky has a blue color, and kind of with sunlight also going around, you can see some things over here in the clear solution because it's not truly clear. If it was truly clear, you would not get to see anything because there would be no amount of scattering, and that is mostly the glass doing its work. But yeah, that is something that shows us how the sky acts. Also, sorry. Sorry for the setup change, but this might be another thing you're wondering. What about at night, right? There's also a sky at night, so this is a clear solution. This is the clouded solution a little, in a certain sense, to represent some particles in the sky. So we're going to redo this in the nighttime scenario. And at night, right? What I've done is that I've added a layer of thermocol to simulate low intensity of the light, as in the complete flashlight was the sun, and then I'm blocking off some to reflect the moon. And here also you see that the cup on the right has this kind of a lighter feel than the cup on the left, which is completely pitch black. And if I put more light to focus on the change, it shows that, even at night there is some amount of scattering that is happening even from the starlight that is around us, and hence night is got completely pitch black for us. It's kind of like a violety shade, right? That is because there are a lot of stars also along with the moon, but only with the moon also it is not completely pitch dark, because there is some amount of light that will definitely be scattered even in the night sky. And if the night sky again were clear completely without particles, it would be pitch black like the glass on the left, right? It is not reflecting any amount of light. So we decided that the sky is a natural phenomenon, right? That it is just scattering of light by tiny air particles that we see, and this happens both at day and night. But then what are clouds? We also see clouds during day and night, and they are different from the sky, right? So obviously something different is happening there. What's happening is that clouds, as you might have learned from elementary school, are water particles, right? They are condensed water up in the atmosphere. But what makes clouds different from the water we see here? Well, water we see here is transparent, right? But not so much up in the atmosphere. When you have enough water concentrated together, you can have scattering that happens even with water particles. I mean, the air here is clear too, right? But the air particles up in the sky are scattering blue light. Similarly, water particles also scatter the light, but they don't just scatter blue light. They are big enough to scatter all sorts of light: blue light, red light, and everything in between. So they appear white. They are condensed packets of water, right? So they are a collective, they are a union of a lot of water particles, and so we see them in a sort of cloudy shape. They appear clumped together, sort of fuzzy, and sort of circular, because sort of curved in a certain sense, because water droplets, when combine, take up roughly a circular shape, and that's what gives clouds their particular appearance. So that is what clouds are. Clouds are whatever we see in the sky that reflects all sorts of light, and that happens to be water particles, condensed water particles high up in the atmosphere. So, to prove that clouds are white in color and the sky is blue in color, this is kind of an analogical experiment. So, what I have is, this is the sky, which is kind of clear, mostly clear. So, you can kind of see the X marked below it, right? Uh, but this is the cloud. The cloud is more opaque in a certain sense. It is more filled with particles of water. And this has similar particles, kind of like the sky, but these are more scattered around, while these particles are more concentrated, right? You can obviously tell by the clarity. And even there is a crossover here, but because it is opaque in nature, it is not clearly visible. So let us check out what happens when I put light on it. So I'm switching off the light so that we get a more clear view of, this is the sunlight. It's not the moonlight, but as you can see, this is trying to simulate a singular ray of light and what color it gives to the cloudy and sky solutions, right? The sky is more of a bluer shade, right? In a certain sense, I've increased from a ray to a beam in a certain sense, and from a beam you can see the clear difference. That is white, that is perfectly white, because everything is being scattered, while on the left, with a more colloidal solution, some of the higher wavelengths are only scattered, right? Only blue. And the solution on the right, it's white because there's a lot of scattering that's happening. This perfectly shows it. See, white clouds and blue sky. It's the same light from the sun, and yet the concentration of particles, the concentration of water in the air matters because water is technically everywhere, but it's in a higher concentration in the clouds, and that gives it the difference. That makes the difference in the lighting of clouds and the sky. So that's one aspect. And then you might wonder why clouds even different at moonlight. And so I decided to do the same experiment with a lowered intensity again to showcase the moon. And so here we go. It's kind of similar where you see the night sky is kind of dull and it's grayish in a certain sense because it's only moonlight, not a lot of starlight here. And the clouds are there, but the clouds are definitely distinct from the night sky, right? If you can see that clearly, it's more white, it's more opaque in a certain sense, and you can make out that they are not exactly the same color, and the opaqueness is more visible in a certain sense. We'll come back to that later, but it is definitely different from the plain night sky. It's the same colloidal solution as in day, so there's a lesser amount of scattering at night, apparent, but yeah, there's a clear difference.
So, this is the final experiment that will help us understand why clouds are fluffier during the day and more three-dimensional at night. And this is a pretty simple experiment that I think you guys can do with me if you have the materials. It's not a lot. You'll require a torch and a piece of paper. Yeah, that's it. That's literally true materials. Hopefully the piece of paper has something written on the back side and on the front side. So this is a piece of paper which has a lot on the front, and behind it it's like half a page of content. Okay, and hopefully to do this you will need something like a pair of sunglasses, and those are optional, but I suggest you wear them if you want to look cool. But and to protect your eyes, that's mainly why you wear sunglasses. But for this I will need a dim setting of light, and I can't get these house lights to dim, so I'm just going to switch them off completely. And then I'm going to get a setting of where the sun might be and then where the clouds might be apparently, and try to produce the effect. So if now that there is complete darkness, if I'm going to position the torch in the place of the sun and I switch it on, this is something that you might perceive in clouds. This is the type of clouds that you get during the day, right? The front and the back side are not that evident. Maybe they are, maybe they aren't, but especially with the sun blocking half of your view, it's really hard to tell. And even when the sun is not, it's not that evident unless the cloud is particularly close to you, right? But to simulate the moon, I could do it two ways. One is I could use myself as a reflection because the sun's light is reflected, right, to the moon, and then me being a rough surface, not a perfect reflection, there's a loss of intensity. But you see what it did there, right? It bifurcated, it increased the contrast on this, on the front and the back side. You see the front is more darker than the back of the page, which is closer to you, is more darker than the front of the page, which is a little grayer in this aspect. And it's giving this illusion of depth. One other thing that I could do to suggest if this is the sun is show that this is kind of the moon. I'm reducing the intensity with a piece of thermocol, and then we get roughly the same effect, right? You'll get the front of the face, which is highly contrasted, and then the back, which you can see, you can make out because of the difference in contrast. And you could even do that with the sun in a certain sense. The sun is just going to make it tough for you to read things, and thus having a lot of light plus having a high intensity of light means that there's going to be a lower contrast that you can adjust your eyes and read too. So that's one thing. What about the fluffiness, right? One thing that I would want to test out is what if we were looking at the edges of the map, right? If this is the sun, then these are the edges, but there is a higher sense of detail that you get, right? Over here, you get a lot of the details in a certain sense. The clouds that you see, you get the fluff factor because there are thickness and thinnesses to this. You get a sense of fluffiness from the paper because you get some dark areas, some light areas, and that could be translated to fluffiness. Now, if I add my moon here, yeah, notice how a lot of the fluffiness is gone. There is still a little fluffiness, but the fluffiness is very minor. While if you're looking at the sun here, you'll just notice that there is a lot more fluffiness involved. Yeah. Let me see if I can illustrate that in a certain point of view. This is the sun's fluffiness, and this is the moon's. Well, I need it to be bigger, so there we go. The moon gives the clouds more depth, certainly, while the sun does not give it more depth. Let me just make it equally half. Yes. So the moon gives it a certain depth, but the sun gives it a more fluffy feel. If you can feel the textures here are more vibrant on this side than on the moon side. So, yeah, that's one thing. So, that is the simple experiment that helps us decide of how fluffiness is impacted with intensities of light and how dimensionality, how depth is impacted with light. So that's a simple experiment that kind of suggests possibly why this might be a reason of why fluffiness and three-dimensionality are seen in days and nights.
And with that, our journey comes to an end, and this chapter on this question of clouds closes. So, hopefully, you had fun and it was engaging, and more importantly, that you learned something. As always, enjoy.